Hello, my name is Nicolas Kristanto, and now I want to present to you about artificial neural network. So, the content of the presentation will be introduction, explanation, case study, coding, and closing. So, artificial neural network is a computational model that inspired from human brain, and it's also known as deep learning machine. A machine learning that mimic human brain by combination of data input, weights, and bias. So let's dive into more explanation. So artificial neural network are machine learning algorithms that, as you know, mimic the human's brain by mimic the human's brain signaling. And they consist of node layers that called input layers, hidden layers, and output layers. And artificial neural networks are powerful tools in computer science and artificial intelligence. So there is many powerful tools in computer science and artificial intelligence, but one of them is artificial neural network. Why? Because they improve accuracy over time, which making the task like speech recognition and image recognition faster. The case study or the example that we use for this for the practice of artificial neural network is house price prediction. So there's a man who wants to buy a house. The price is unknown. The value, if it's above or below the median of the price. So we need to predict it to help him. How? We can predict the price. Well, we can predict it using artificial neural network or shortened as ANN. First, we were given the file in CSV file. And now in Jupyter Notebook, we need to call it or we need to read it. So this is how you do it. Import pandas spd dfpd. Okay, and this is the data in Jupyter Notebook when called by df. Df is come from here. So house price data.csv is the name of the file, and make sure that the name is correct, and also the file, the CSV file and the Jupyter Notebook file is in the same path or in the same folder. But if it's in document, make sure it's in document. If in separate folder, it will not recognize. Okay. So now the data set is in that pandas data frame. We need to convert it to array. So here's how we do it. And this is the data set. And now we split the data set. Wait, okay. Usually, oh, sorry. Okay. Usually the data is normalized, but in this case, the data is not normalized. So we have to normalize it. Why? Because we want the input features to be on the same order of magnitude. So make the training easier. So we will use min-max scalar from scikit-learn, which, or you could say, use to scale the data between 0 and 1. And this is how you do it. Lastly, we need a set of data set, a set or some parts of our data set for a validation set and a test set. So we use train test speed function to do that. And here's the result. Okay, now we begin to building that and training our first neural network. And in this section, we'll be using Keras to build the architecture. Let's import it. And as I told you, we need we have layers, right? And we using sequential model, so we need to describe the layer. And in this case, the artificial neural network has 3 layers. Why? 3: hidden layer 1, hidden layer 2, and output layer. Input layer usually doesn't count in here, so that's why it only count 3. And so we name it model, and we've got the architecture specified, but we need the best number for it. Before we start, we have to configure the model by telling the algorithm, the loss function to use, and the other metric that we want to track apart from the loss function. Okay, so we how do it. And now the data pretty straightforward and requires only a line of code. The function called fit for fitting the parameters the data. So we need to specify the data with training, in this case X train and Y train, the size of mini batch, how long we want to train it, and the validation data. So the model will tell how we are doing on the validation data at each point. The the function will output the history and will save it on the variable history. And now we need to evaluate the data. And now, after we evaluate, we visualizing the loss and accuracy. So first we need to import, and now we visualize. Okay, this is a visualization. And this is another visualization that you can do. So there's the visualization. And now we adding regularization to our neural network, which we call it model 2 for overfitting. And this might take a few minutes. And now we do the same visualization for the loss and accuracy for model 2. Here and here. So there's 2 models. And to address the overfitting, we will incorporate auto-regularization and dropout in third model. Here's. And now we will plot the loss and accuracy graph for model 3. And you will notice the loss is a lot higher at the start. It's because we changed the loss function. And to plot it, we need to zoom the windows between 0 and 1.2. And we add a line of code PLT while when plotting. This is the first visualization, and this is the second. So as compared to model 2, you should see that there's less overfitting. Okay, thank you. Arigato. 谢谢. Kamsahamnida for listening the presentation. Goodbye.